Okay, so let's continue our conversation with complex numbers. Complex numbers, remember, are your imaginary numbers. Think about the two key pieces of information that you need to know for complex numbers. Think about what those are. Hopefully you're able to figure out and answer that question in your head. Two key pieces of information for complex numbers, what are they? Okay, so let's kind of pick up where we left off. I'm going to start with example 2. If you take a look, we are multiplying complex numbers. I want you to look at letter A. There are two binomials. Look at letter B. There are two binomials. How do you multiply two binomials together? You should be saying to yourself, I know that when I multiply two binomials together, I use the FOIL method. Remember FOIL, first, outside, inside, last. So let's kind of get some practice with that. Take a look, letter A. If I were to FOIL that, first, outside, inside, and last, I would get 10 minus 2i plus 15i minus 3i squared. Remember, I times I is I squared. From here, we can simplify. Remember that we know I squared is equivalent to negative 1. So I have replaced I squared with the negative 1. Let's simplify this even further. Okay, so when I do the negative 3 times negative 1, I know I get positive 3 there. From here, again, combine your like terms. 10 and 3 is 13. Negative 2i plus 15i is 13i. Remember to write that in standard form. The real part first, the imaginary part second. Looks like that is your answer because you can't combine them. They are not like terms. Second one, letter B. Again, same deal. FOIL those. First, outside, inside, last. You should get something that looks like that. From there, again, we know I squared is equivalent to negative 1, so if you need to replace I squared with negative 1, great, do that. Simplify that even further. Negative 25 times negative 1 is positive 25. Combine your like terms. Notice 9 plus 25 is 34. Positive 15i and negative 15i, they cancel each other out, so your answer is just simply positive 34. Something that's going to be important with these, take a look. If you look at the problem again, you have 3 plus 5i and 3 minus 5i. It's going to be important that you know that they are called complex conjugates of each other. Complex conjugates are separated simply by one's going to be an addition sign, one's going to be a subtraction sign. Something that I think you should put in your notes from here, notice what happens with complex conjugates. That outside and inside term cancels itself out. I would put in my notes that when you multiply by complex conjugates, that outside and inside will always, 100% of the time, cancel each other out. And you should be able to save yourself some time when you notice complex conjugates. You'll only have to multiply the first and the last terms together. Something I think very important to put in your notes. Okay, as we keep going, take a look, letter C. First thing, remember that you always want to make your negative square roots positive. Think about what we did yesterday. You always want to make them positive first, so go ahead and do that. Square root of negative 4 is 2i. Square root of negative 9 is 3i. If I multiply the two of those together, think 2 times 3, I times I, you should get 6i squared. Well, you should notice I squared is equivalent to negative 1. When you multiply those, your answer should be negative 6. Okay, so always make your negative square roots positive first, and then simplify from there. So, same deal, letter D. make sure you do same thing. Try to make them positive first, then try to simplify from there. Let's see what happens. Okay, so I made square root of negative 6 into I root 6, and the square root of negative 3 into I root 3. Neither of those can be broken down, so I'm going to leave them like that. How do I solve this from here? Well, I think you should be saying to yourself, okay, I think what we should do is distribute. So let's do that. If I distribute, notice the 2 and the I are on the outside, so I'm going to multiply those to get 2I, tack on the root 6, distribute to the other one. I times I is I squared, root 6 times root 3 is root 18. Okay, some things that should be sticking out. Obviously the I squared and the square root of 18. Both can be simplified further, so think about that. I changed the I squared to negative 1, and I changed the square root of 18 to 3 root 2. Simplify that one step further. Negative 1 times 3 is negative 3. 2I root 6 minus 3 root 2. Be careful, that is not in standard form. You want to make sure you rewrite that and put that in standard form. Real part first, imaginary part second. Looks like that'll be your answer there. Okay, dividing. This is where it starts to get a little bit trickier, so I'm going to take this a little bit slower so you can see the dividing part of this. I have 2 over 3 minus I. We're not allowed to have the I in the denominator. Think I is equivalent to the square root of negative 1. You're not allowed to have square roots in the denominator, so you have to get rid of them. If you remember from Algebra 2, what you do is you multiply top and bottom by that square root. This gets a little bit more involved because now you have this 3 minus I. So what I would put in my notes to get rid of that, you're always going to multiply by the complex conjugate. So think, what is the complex conjugate of 3 minus I? You should be saying to yourself, okay, the complex conjugate is 3 plus I. So multiply numerator, multiply denominator by 3 plus I, and then just simplify from there. So the numerator, you're going to distribute, so you'll get 6 plus 2I. The denominator, here is where you're going to save yourselves a lot of time. When you multiply by the complex conjugate, think the outside and the inside are going to cancel each other out, and therefore I only need to multiply my first and last terms. So first times last should give me 9 minus I squared, and then just kind of start simplifying from here. I squared is equivalent to negative 1, so 9 minus a negative 1 is actually 10. Think about what we did yesterday. If all 3 of those can be divided, you should divide them. So I'm going to go ahead and do that to give me my answer of 3 plus I all over 5. Letter B, again, not allowed to have square root in the denominator, so same deal. Multiply top and bottom by that complex conjugate. This one's a little bit trickier because now you're going to have to FOIL in the numerator. Notice that they are not complex conjugates of each other, so I actually have to FOIL them. So I showed you that. Denominator, they are complex conjugates of each other, so I simply need to multiply the first and the last. Do some simplifying from there. Remember, I squared is equivalent to negative 1, so positive 3 times negative 1 is how I got the negative 3. Negative 9 times negative 1 is how I got the positive 9 there. Continue to simplify. You get, combine your like terms, 7 plus 17i all over 13. Can't be reduced anymore. Looks like that will be my answer. Okay, last two. Let's see, maybe we'll be able to go a little bit faster. Multiply by the complex conjugate. Foil them. Numerator, first and last in the denominator. Simplify. Combine your like terms. I notice all three of them are divisible, so I'm going to do that. Looks like I get 1 minus I. Okay, letter D. Again, come on, notice a theme. Your square roots, make them positive first. Okay, square root of negative 36 is 6i. Square root of negative 9 is 3i. Here you have some options. I notice that all of those are divisible by 3, so I'm actually going to divide them. If you did not do that and you decided to multiply numerator and denominator by the complex conjugate, you would still get the same answer. Just a little, you'd have to do some reducing at the end. I'm just going to reduce right now. So notice how I reduced them. That gives me this. Now I'm going to multiply by the complex conjugate. Foil the numerator. F and L, the denominator. Simplify. And positive 2 looks like that is my answer.